Lastly, we have the topic group code, which is a very important part of coding theory and communication theory, as it helps us to encode words, decode words, error detection, and error correcting. So in this, a group code has a set Bn, which consists of binary numbers x1, x2, x3 to xn, which are of length n. So supposedly, if the value of n is 2, then B2 can contain any possible combination of these four values. But the value of 2 is very important because only binary numbers of length 2 can exist in the set. And all these sets Bn are under the binary addition operation. So the rules of binary addition are very simple. 0 plus 0 gives 0, 0 plus 1 gives 1, and 1 plus 1 gives 0. So since we can see that the answer side, the RHS side, consists of zeros and 1, and the LHS side also only consists of zeros and 1, the closure property is true. So for a group Bn, the binary number consisting of only zeros of size n is considered to be the identity element, because addition of any either 0 or 1 gives the number itself when it's added to 0. As you can see, 0 plus 0 gives 0, 1 plus 0 gives 1. So if we take this number, for example, 110001, if we add 0 to this one, it will give us 1. If we add 0 to this one, it will give us 1. If we add 0 to this 0, it will give us 0. Similarly, here also we'll get 0, here also 0, and here we will get a 1. So in the end, we'll get the number itself. Therefore, that is the identity element. Now, moving on to inverse, every number is its inverse. That means that when we add the number, when we perform binary operation on the number itself, we get 1 plus 1 gives 0, 0 plus 0 gives 0. Similarly, here also 0, here also 0, and 1 plus 1 0, 1 plus 1 0. So therefore, inverse exists for every single element present in the group Bn. Therefore, this is also true. And as we know that addition is commutative and associative, so we've proven that Bn comma plus is a group code. Moving on, so an encoding function is used to encode the words in which we're given in a generator matrix, and then after the word has been encoded, we are given a parity check matrix which helps us in decoding the word. So this is very important, and I'm going to explain this properly in the question after the topic is complete. So weight of a binary string, this basically means the number of ones existing in the binary number x, which belongs to Bn. So the d of x is given as mod of x, and so mod of 11011 gives 4. So Hamming distance is related to weight of a binary string, as when we perform the binary addition of two numbers x and y, the mod of these two numbers gives us the Hamming distance. So if we suppose that the binary addition of two numbers gives us 1101, therefore the Hamming distance would be 4 in that case. Now, Hamming distance is important because we have to find out the minimum Hamming distance after performing binary addition and finding the mod of that binary addition for every single possible combination of x and y belonging to Bn. I'll show you that in the question also. But we have to equate the Hamming distance to at least k plus 1 for the system to detect k errors. So this means that if the Hamming distance is 4, so we have to equate the value of 4 to k plus 1, which gives us at most 3 errors to be able to detect it. Now, similarly, if the code, so the code can correct at most k errors if the minimum distance between any two code words is at least 2k plus 1. So if we take the value of 4 here, so at least 2k plus 1, so that means 2k plus 1 has to be greater than 4. So what value of 2 satisfies that? So we get 2 into 2 plus 1 is 5, which is greater than 4, so 2. That means code can correct at most 2 errors.